right? So I want to revisit this, our exponential function. So I want to revisit y is equal to 2 to the x. You don't have to write this down. You can just watch, right? So I'm going to revisit y equals 2 to the x, and I want to kind of go over our chart. So here's my little xy chart, and I'm going to pick my favorite values, which are going to be -2, -1, 0, 1, 2. And when I plug 0 in, I get a 1. When I get 2, 4, 1/2, 1/4, right? This is all supposed to be review, right? And so I'm here, I'm here, I'm here, I'm here, I'm here. And we have our asymptote at 0, and we end up with this picture. Is everybody okay? This is the graph. This is our graph of 2 to the x, right? I mean, I made you graph a whole bunch of stuff, but here's our graph of 2 to the x. All right, well, I'm going to pick up a different color marker, and I want the inverse. All right? I am interested in a graph of the inverse of this. Right? And so how do you find the inverse of anything? You swap x's and y's, right? The rules don't change. And so when I swap x's and y's, I've got this little chart. I'm going to make a chart of the inverse, and I'm going to swap x's and y's. So that's simply, here's my x, here's my y. And now instead of -2, 1/4, I'll have 1/4, -2. I'll have 1/2, -1. I'll have 1, 0. I'll have 2, 1, and then 4, 2. Okay, all right. I have trouble swapping. All right, are we okay with that? And I want to know what this graph looks like, so I'll plot it. And so let's see. At 1, I'm at 0. At 2, I'm at 1. At 4, I'm at 2. At 1/2, I'm at -1. 1/2, I'm at -1/4. Are we okay with this part? All right. Also, whoops, I forgot about this. I needed to talk. Back to the blue graph, let's talk about domain and range. What's our domain of the blue graph? Everything. Are we okay with that? -infinity to +infinity, all the way left, all the way right. So our domain here is -infinity to +infinity. What's our range of the blue graph?
0 to infinity.
Are we okay? 0 to infinity. So that's going to give me 0 to infinity. Are we okay? Now, notice in the blue graph we have a horizontal asymptote, right? When you do the inverse of this, we're going to get a little vertical asymptote. And can you see, let's see, this graph? Okay. And when you graph a function and its inverse, it should look like a little mirror image over this y equals x line. And does this look like our little mirror image? Right? All right, well, I have this new red graph. And in a new red graph, let's talk about domain and range. Oops, it's red graph, so we'll use the red marker. Let's talk about our domain. So what's our domain of the red graph? How far left and right does it go? How far to the left does it go? 0. Doesn't include it. How far right does it go? All the way. Let's look at our range. How far down does it go? -infinity. How far up does it go? +infinity. Are we okay that the range goes from -infinity to +infinity? So what can you tell me about the relationship between the domain and range of the blue graph and the domain and range of the red graph?
Just flipped.
Of course it's flipped, right? See, the reason I'm being obnoxious here, right? Of course it did, because domain is basically your x's and range is basically your y's, right? And when you do the inverse, what do you do to the x's and y's? You swap them. So does it make sense that the domain and range got flipped from here when we're doing the inverse? All right. So is everybody okay with my red graph? Well, we can't just keep calling it the red graph. We need to name it. Right? I thought about naming it Bob, but that doesn't seem very math-like, right? I mean, you have to name something a little more precise than just random names. And the way we're going to name this graph is, it's got a special name. It's going to be y is equal to and it's going to be log base 2 of x. Right? Where the log and the x are all on the same line, and you have a subscript of 2. Right? That's all you do, right? Now, so, and this is read log base 2 of x, and that actually gives you an idea what we're talking about today. Today we are talking about logarithms. What exactly is a logarithm? Well, right now, what you know about a logarithm is it's the inverse of an exponential. Because this is an exponential function, this is a logarithmic function, they're inverses of each other. Right? Now, normally, had my device worked like it was supposed to, we would be doing a whole lot of stuff with a graph of a logarithm. Right? Remember how we started with exponential stuff? I said, here's the graph of an exponential thing, and we played with that for a day. Then we did stuff with an x, and we solved. My original plan was, okay, here's the graph of a logarithm. I'm going to make you do some stuff with the logarithm, right? But we're going to do that on Monday, right? Because I don't have a way to distribute it today. So today we're going to work with, what exactly is a logarithm, how do you compute stuff with it. But we're going to come back to the graphs, I promise. We're going to deal with the graphs on Monday, right? So this is read log base 2 of x, right? And the significance of this 2 it's related to this 2. Like we have different exponential functions. Like I've got 3 to the x, 4 to the x, 5 to the x. Well, you got different logarithms. You got log base 2, log base 3, log base 4, right? Whatever this is, it's the inverse of this part. Is everybody okay? All right. So we're going to come back to the graph Monday. We're done with graphs today. Today is about how do you... Oh, we're going to talk... So we're going to... there's 2 versions... I guess I should do this. So what I'd like you to do on your notes is I want to make 2 columns, right? So make sure you have room for 2 columns.
All the way down?
You're going to write like maybe 5 or 6 rows, right? But you don't have to go all the way down. Just get about half the page, all right? So on the left side, we're going to call it logarithmic. And then on the right side, we're going to call it exponential. Okay? And what we're going to do is we're going to convert from logarithmic to exponential and exponential to logarithmic. And let me explain exactly what that is. So what I want everyone to do, on the logarithmic side, I want you to write log base 2 of 8 is equal to 3. Give everybody a chance to write this part down. All right, log base 2 of 8 is equal to 3. Everybody write that? Everybody got that down? And I know my handwriting's awful, so I want to make sure everybody understands. The log, the 8, the equals, and the 3 are all on the same line. And then you have a base 2. All right, and the 2 is a subscript. All right, now, this is like a logarithmic equation, right? It's got an equals and an expression. And we need to convert this to an exponential, all right? And here, how we do this, right? I'm going to preface this whole thing. This is my non-technical term. Nobody else uses this term, right? If you try to use this in a different class, everybody's going to look at you funny, right? After we do it a few times, I'm going to explain why I use it. Got it? So here's how you compute it. What I want you to do, take the base, right? You take the base, and then you say the word swoop, and you go swoop and push that up to an exponent. And when you do swoop and you push that up to an exponent, you end up with 8 is equal to 2 to the 3rd power. Everybody see the swoop? Okay? So when you do swoop, we get 8 equals 2 to the 3rd power. All right? So I'm about to throw some terms at you, and I'm going to repeat these over and over, so if you don't catch it the first time, that's fine. All right? Turns out a logarithm is an exponent, and that phrase may not make a whole lot of sense now, but it will in a few days, but I'm going to say it. I'm introducing it now, right? So a logarithm is an exponent, and how you get from a logarithmic to an exponential formula, exponential is, I call it swoop. Right? Why do I call it swoop? Well, anytime I can sort of animate math where you see it's a procedure, right? You're not just memorizing a step, you're actually moving something. Anytime it's animated, you have a better shot of remembering it. And particularly, if I use the word swoop, doesn't that kind of describe what you're doing? It makes it easier to remember. And I'm not interested in, my goal isn't for you to remember it next week. My goal is for you to remember it next year or 2 years from now, right? All right, so your turn. If I give you, let's say I give you log base 9 of 3 is equal to 1/2. And so I want everybody to, so swoop is this way, right? So put it in exponential form, everybody do swoop. That's a 9. All right? Has everybody got it? And if you do swoop, right? We take our base and we go swoop, then that's going to give me 3 is equal to 9 to the 1/2. And actually, if you think about it, isn't something to the 1/2 power, isn't that the square root? Are we okay at square root of 9 is equal to 3? Is everybody with me so far? Okay. So how do we feel about the swoop principle? Right? You take the base and you go swoop, right? You have to emphasize the swoop part. You just can't say swoop. It doesn't work. You got to go swoop, right? You have to really do that, right? And then you get exponential, all right? Well, if we can go from logarithmic to exponential, well, we have to go backwards. So meaning if I give you, let's see, here, let's write an easy one. Let's say I have 4 squared is equal to 16. Can everybody agree this is an exponential equation? Okay? And so how to write this logarithmically, we're going to go backwards. Right? And when you're writing a logarithmic equation, there's 3 spots. So I'm going to write this. So we're going to have log, we've got a base that we've got to talk about, we've got a value here, and then it equals something over here. Does everybody see we've got 3 spots we got to fill in? Which is convenient, right? Because we have 3 numbers, right? Where do these numbers go? Well, easiest one to find out where it goes. Remember I told you logarithms equal an exponent? What's the exponent over here? What's the exponent over here? 2. Is everybody okay? Next, what's your base? What's your base? 4, right? Everybody okay when you have an exponential thing? This is your base, this is your exponent. Well, if their base is 4, I said log base, that means there's a 4 that goes here. Everybody got that? We only got one other spot and one other number, so I guess that means the 16 goes here, doesn't it? Now here's the great thing about it. How do you know if it's right? You do swoop, and if I do swoop, do I get this? Right? So for years, I think since my my first year teaching, I called this swoop. But about 10 years ago, someone says, well, why don't you call this direction, why don't you call it poos? I don't know why someone would tell me to write it called poos, right? Swoop backwards. Right? Well, y'all are a tough crowd. All right, now. All right, so your turn, right? So if I'm going to give you the exponential one, all right, and I want you to put it in logarithmic. So if I give you the exponential of, let's do 27 to the 2/3 is equal to 9. So given that exponential expression, write the logarithmic version. Does everybody have it? Okay, so what you should have is, well, let's see, I'm going to write down log. My exponent is 2/3, so I know it's going to equal 2/3. My base is 27, so I'll put a 27 here. And then what's left is 9, and kind of the final check is, if I do swoop, do I get this? And then I know it's right. Okay. How's everybody with converting from logarithmic to exponential and exponential to logarithmic? Are we getting more comfortable with the swoop principle? Okay, good. All right, so now, well, how do we compute stuff? So, here, I want everyone to write down, and you already know the answer because I've done it before, but I want everyone to write down, do log base 2 of 8. So everybody write that down. Right. This is a number. Now, I'm going to tell you what I was told, and then I'm going to translate it. Because, what I was told was correct, but it's confusing, right? So whenever you see log of something, it's really 2 to what power gives you 8. And that's what my Algebra 2 teacher told me, and I'm like, well, that doesn't help me. Okay. So here's what I want you to do. Has everybody got log base 2 equals 8? Got log base 2 of 8? What I want everyone to do is put an equals x. Everybody put an equals x? Okay. And our job is to figure out what x is, and now what I'm going to do is the swoop principle. So I'm going to take this and go swoop, and so that's going to give me 8 is equal to 2 to the x. Does everybody see how I did the swoop thing? And so you got to think 2 to what power gives you 8? So 2 to what power gives you 8? Everybody okay with 3? So 2, so we just found out that x equals 3. So we just found out log base 2 of 8 is equal to 3. Does that make sense? All right. So here, let's see how you do with this one. What if I give you oh, actually, I can get by with this. Let's do log base 16 of 4. Okay? So again, if you approach this the same way, okay, we set that equal to x. When I do swoop, I get 4 is equal to 16 to the x power. 2 ways to do this. One is, do you recognize that you could do this exactly the way you did it yesterday? Do you recognize your common base is 4? And so if you recognize your common base is 4, you can say this is 4 to the 1 is equal to 4 squared. So you end up with 1 is equal to 2x, or x is equal to 1/2, right? Everybody say you get 1/2? The other way is you could look at, well, how do you get a 4 from a 16? Take the square root. What exponent represents the square root? 1/2. Does that make sense? All right. Well, what if I give you log base 3 of 1/9? Everybody got an answer? Okay, so I'm going to set this equal to x. Do the swoop principle, so I get 1 over 9 is equal to 3 to the x. Right? What's x have to be? Is everybody okay with negative 2? Do you see why I have to have a negative to get the fraction and the square? And so we end up with, x equals negative 2. If you don't believe that, you can say, well, what's 3 to the negative 2? Oh, that gives me 1 over 3 squared, which is 1/9. Are we okay with these computations? All right. There are a couple of patterns I need to make sure we know. So, pattern number 1. What is log base 3 of 3? So everybody write down log base 3 of 3 and compute it. What'd you get?
1.
Everybody get 1? All right. If you go through and say, okay, I'll set that equal to x, I'll do swoop, 3 is equal to 3 to the, oh, it's got to be 1, doesn't it? All right, well, okay. What is log base 7 of 7? 1. Are you kind of visualizing it? Setting equal to x, doing the swoop, it's got to be a 1. All right, so in general, your rule is, that's 1, log base happy face of a happy face has got to be 1. Anytime these are the same, you get a 1. Everybody okay with that? Okay, next little pattern. What is log base 4 of 1? What'd you get?
0.
All right. So if I set that equal to x, I'm going to do the swoop. 1 is equal to 4 to the x. Well, 4 to what power? Well, the only way that's going to work is if you get 0. And so this equals 0. All right. Well, what if I gave you log base 6 of 1? What's that going to be? Okay, that's also going to be a 0. So our next general rule is log base anything of 1 is going to be 0. So far, so good? All right. Well, what is log base 2 of negative 4? What'd you get? Anybody confused with this? Is this weird? Good, it's supposed to be weird. So if you set it equal to x and you go swoop and you get negative 4 is equal to 2 to the x, you think 2 to what power gives you negative 4? And can I raise 2 to any power and get a negative number? No, right? Because if the positive number gets bigger, negative just gets smaller, right? Can everybody agree there's no way this is going to happen? So you know what log base 2 of negative 4 is? Error. Not possible. Bad. I'll just say bad. All right. If you type this in your calculator, it would say error. Can't do that. The same way, it does that the same way, like if you've ever tried to take the square root of a negative in your calculator, what does it say? Error, right? If you ever divide by 0, error, right? So this is actually a big deal because we now have, right now, up until today, you had 2 rules in math. Your 2 rules in math are, you can't divide by 0 and you can't take the square root of a negative, right? Everybody okay with those rules? We now have a 3rd rule. You can't take log of a negative, right? And we knew that. See, remember when we graphed this whole thing? When we graphed the, shoot, I can't remember if it was red or blue. Was the exponential thing blue or red? Blue, okay. Not the exponential, the logarithmic, was it blue? This was red? Okay. Remember when we did the domain and range? The domain for our logarithmic graph, because our graph kind of looks like this. We had our domain was 0 to infinity. Remember that was our domain? Domain, those are legal values. Those are the values you can use. Notice you can only use positive values, right? There's nothing to the left, so you can't plug in a negative. And actually, can you do log base 3 of 0? Because this would be saying, okay, 3 to what power gives you 0? It never gets to 0, right? Which is consistent with your domain, right? You can't take log of 0 or negative. So if you ever have to do it, you'd say error or bad, I can't do that or whatever. Does that make sense? All right. I got one more thing I need to talk about, then we'll get started on your work. And the one more thing I need to talk about is there's certain so there are lots of bases, right? Log base 2, log base 3, log base 4, log base any number. The bases have to be positive. Right? If the bases aren't positive, it doesn't make sense. But all right, so you can have all these different bases. The engineers, they would do log base 10 a ton, right? They kept using log base 10 a lot. And they got tired of writing the base, right? So what they did is instead of writing log base 10, they just write regular old log. Anytime you just see log with no base, it's an assumed 10. Right? Every logarithm has a base. If you don't see it, it's an assumed 10. Okay? Everybody okay with that? So, just curious here, let's look at, if I ask you to compute log of 100, well, if I set that equal to x, and I do my swoop, I do an imaginary 10, and then I swoop over, so I get 100 is equal to 10 to the x. So 10 to what power gives you 100? 2. Are we okay? So log of 100 is 2? Okay. Oh, actually, if you have a scientific calculator, take it out. You don't have, it could be the graphing, it could be any scientific calculator. But if you've got one, I want you to take it out. And what I want you to do you see a log button on your calculator? Does everybody see the log button here? I'm afraid to actually do anything on my computer because it's kind of scary. But if you look right here, there's a log button. Now, I'm not so interested in the log button. What's right above the log button? Like the secondary function if you hit shift.
10 to the power of x.
10 to the x, right? Like when you look at this, and this is not just the TI-84, this is pretty much any scientific calculator. If you see a log button, right above it is 10 to the x. Why do you think those are associated? Because they're inverses of each other. Remember, a log base 2 and 2 to the x were inverses? Someone put some thought into that, right? So, just curious, since you've got your scientific calculator out, what's log of 100? Actually type in log and put 100. What does it tell you? 2. Right? We know it, right? What if I gave you log of 0.001. Let's figure out how to compute this. Well, I know you can type it in your calculator, right? Yeah, it's really not much of a question at that, right? How do we do that without a calculator? Well, if you think of this as log base 10, right?
I just did it.
Set that equal to x, and this is a 10. When I do swoop, this is 0.001 is equal to 10 to the x, right? And you think, well, how can you answer this, right? Well, are we okay that this is, the 0.001 is 1 over 1,000?
That's like scientific notation.
Yeah, this is scientific, but this is like 1/1000th, isn't it? So this is 1 over 1,000. What does the exponent have to be so that we get 1 over 1,000? -3, right? The negative because we get a fraction and 3 because we have 3 zeros. Does that make sense? Yes?
Just a question.
Mhm.
What were engineers using log 10 for a bunch of
Why? Well, we have, here, let me go ahead. I don't think we need this anymore.